Okay, class, let's continue our solution to letter E. So we are asked to find the minimum area of the stirrup based on the code requirement. So the first thing we have to check on before we use the formula is to look into the spacing that we have computed or calculated uh, in letter A and B, okay? And choose the larger spacing, which will give us the more conservative a value for your uh, minimum area of your stirrup. Okay, so the spacing S is obtained from the required or the calculated spacing or the design spacing. So you may opt to choose. So here what I did is I selected the larger of the two spacing that we have calculated and designed, and it's a comparison between 212 and I think 175 millimeter. So we choose the larger, which is 212, and simply take note of the given value for your BW and FB. Okay, so FB here is the yield strength of your stirrups. Okay, in case FB is not given, you may use FY if FB is not available. Okay, so we simply plug in the value BW S all over 3FB. So we yield 102. Of course, the unit here is in millimeter square. Now, for your conclusion, we have to compare it. Okay, so there will be a comparison from the code. Okay, so this is the code formula. So we will be comparing it to the actual provided AV. Okay, so we take note that AV here was used, this was used in the formula of S. Okay, okay, AVFP all over so this is D over VS. Okay, so whatever is your AV that was computed there, which is a 10 millimeter diameter two-legged stirrup, so this will be our value to be compared to AV minimum. Okay, so this is now greater than AV minimum. Of course, the furnished area must always be greater than the code limitation to make a safe design. So since 157 is greater than 102, then the design is okay. So that's how you check your minimum area of stirrups. For your maximum spacing requirement, there's an error here in the lecture. Your S max is again uh, provided in the code to be equal to two possibilities or two values, actually four values, which is d over 2 and 600 or d over 4 and 300. Okay, so when do you use this first? You use this first option. Okay, so this is your option number 1 if Vs is less than this value. Okay, take note this value is actually twice your Vc. Okay, this value here is actually 2 times your Vc. So if you know Vc, you just multiply it by 2, you don't have to compute. But if you don't know Vc, okay, I'm referring to Vc of this simple equation, okay, not the detailed equation. Okay, so we have to check this, and number 2, we have to check this. Okay, choosing the larger of the Vs. Here you choose the larger of the spacing. In here you choose the larger of your uh, Vs requirement. Okay, so and compare it with this value. So this is my R larger of Vs in kilonewton. Compare it with 1/3 F square root of Fc prime BWD in kilonewton. So this is less than 321. Hence, S max, use the smaller, okay, of these two here. Okay, either this or that. So D over 2 or 600. So what is D over 2? Okay, so your D is actually in meter. Remember, we converted it in meter a while ago. So this must be multiplied by 1000 here in my MathCAD. Okay, but if you are not using MathCAD, you can, for as long as D is equal to 540, then you don't need to multiply it by 1000. So what I have here is simply 540 divided by 2, which is 270 or 600. Okay, here you choose the smaller. When you are into spacing requirement, you always choose the smaller value because the smaller value will give you a safer design. Okay, so you choose now 270 millimeter as your maximum spacing. Okay, so in the succeeding lecture, a video, I will show you how to arrange these stirrups in terms of spacing. Okay, for you to be able to understand how the AV minimum, how the S max are going to be incorporated in your design drawings. Okay, so for now, that's all for this problem. So I hope you have understood the basic concept, including of course the procedure on how to analyze a simple beam, rectangular beam at that with respect to its shear behavior in strength design method. Okay, so thank you very much. So uh, I'll be seeing you on my next video lectures.